5 or 6. I'm trying to be rude. Jeez. I'm seeing 0.0223. Or 0.233. I'm seeing 0.233. So I don't know if you're right or not, but I'm just saying. It's 0.233. So it's 6 choose 1, so this would be like k equals 1. 0.4 to the first, 0.6 to the fifth. 1 success, 5 failures. This is your probability of success, this is your probability of failure. Then you gotta do k equals 0 also, which is 6 choose 0, 0.4 to the 0, 0.6 to the 6. So when you add them up, you get 0.233. Should I break down the two numbers though? So this is 0.0467-ish. Oh, my bad. And then this is 0.18. Start 0.187-ish. Questions on those? I think I can go through all these two? Okay, so then I'm going to show you how, like, now that I've shown you the formula, we've gone through it, I'm going to show you that your calculator does this way faster. You don't actually have to set up the formula, but it goes a lot better because now you understand what the numbers mean and all that. So let's look at the notes I just gave you. These are all binomial situations, so I wrote that on the board, that's what we're doing it. I never really told you what it was. So there's 4 things that something, a situation needs to meet in order to be binomial. There has to be a fixed number of trials, so a fixed n. So like in all these problems I told you we're flipping 8 coins, or we're flipping 4 coins, or we're flipping 6 coins. The opposite of that is going to be a geometric, and in that situation, we flip until we succeed. So like if I flip a coin until I get heads, do I have any idea how many times I'm going to have to flip it? I do not. Could be 1, could be 10, could be whatever. So that's different. That's like the opposite thing we'll be doing in this chapter. So if you see a fixed number of trials, like we're doing this, this number of times, that's your first clue, it's binomial. You also need a fixed probability. So you can't use this formula if the first coin you flip is, fair, 50%. The second coin you flip is 65%. The third coin you flip is 12%. Like it has to be the same thing every time. Each trial has to be independent. So these are pretty much the same thing. So imagine like picking cards out of a deck. The first time you pick a card, what's the probability you pick a red card? 50%, right? Well, if I don't put it back, Does that change the probability? It does, and then they're no longer independent. So these are pretty tied together. And the last one is you have to have a clear yes, no, where you can think about it as success, failure. Like it has to be obvious. Did you succeed or did you fail? Like a yes, no. There's only two outcomes: yes or no. Not maybe, not kind of. So heads, tails. Make the free throw, you miss the free throw. You pass the class, you fail the class. Alright, here's where you guys are going to get annoyed with all the work we just did. Because your calculator does this so easily. So there's two formulas we're going to use. It's binomialpdf and binomialcdf. So that the only difference is that one letter, P or C. So P finds the probability of getting a particular result, or something about it as a specific result. Like that's not what I do, but some people have told me in the past. Like I think P stands for specific, and I'm like, wait, but specific doesn't start with P, and they're like, yeah, that's specific. Whatever works for you. So if I were to do that one we just did on the board, so the probability of success was 0.4. There were 6 trials. It actually doesn't work for the one we just did. So let's say I want to know k equals 1. So I'm going to flip a coin. The probability that comes up heads is 40%. I'm going to flip 6 of them. I want to know the probability I get 1 success. You're going to type in, you have to write it out, you have to label it. So it's kind of like the normal CDF stuff. You're going to type in this order, N and then P and then K. So whatever weird abbreviation thing you want to do for that. Again, people use this, I don't get it, but people say they use California Pizza Kitchen. But California doesn't start with an N. And then they're like, yeah, but California Pizza Kitchen. I don't understand.
Who is people?
Right. No, this is something that's happened, like, I never mentioned it, and then it'll happen again the next year. And I never bring it up, but it happens the next year. You know? Like,
why don't we do like Nevada Pizza Kitchen?
Well, that's not like a restaurant, right?
It's California Pizza Kitchen.
Sure, dude, I don't care. I don't know. I'm just giving you, like...
It's in Nevada.
California Pizza Kitchen.
Never... I don't know. Make up, it doesn't matter to me. I'm just giving you... Telling you what I've heard in the past. Nevada Pizza Kitchen. NPK. So you're going to go NPK. Never punch kittens. I mean, yeah, you don't, right? So go to, what do you got?
No, I can't say it out loud.
Oh, boy. Well, whatever works for you. So go to second dister. So you go into distributions again. And this can look 2 ways because we got like the different kind of calculators, right? Where some kind of prompt you and some don't. So this one pops up, and this is probably the easier version because it just kind of tells me like how many trials were there. Oh, there were 6. The probability was 0.4, and then X is 1. If you didn't pop up with that, you're just going to put commas in between. So you're going to go 6, comma 0.4, comma 1. If you got an error or something, bring it up. Or yeah. So second, so you should get, let me get the end. So it's 0.1866, just so you know what you should be getting. So you go second bars, where it's like the distributions, like where normal CDF is and stuff. And then you scroll down quite a ways to binomialpdf, P for particular, specific. 6 trials. You can't have 0.6 trials, right? So it's 6 trials. 0.4 is your probability, and then 1. You have 1. You're just looking for 1 success. So how many got that? Are we good? I Too soon. Okay. CDF is like a shortcut that you can use, but you never really have to. So here's what CDF does. Go to the back. If I asked you for, let's say, n equals 10, p equals 0.3, and I want the probability of 4 or less successes. I'm getting there. So you really have two options for doing this problem. One is a lot shorter, but some people get confused by it and don't like it. So you could do that PDF I just showed. You could do PDF with 4, PDF with 3, PDF with 2, PDF with 1, PDF with 0, and add up all of those particular solutions. You know what I'm saying? So 4 means 4 or less. So you could do, don't really write all this down, but I could do binomial PDF of 4 plus binomial PDF of 3 plus blah 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 2, 1, 0. But that's a heck of a lot of typing. It's just kind of a pain in the ass. Pain in the butt. I lost myself for a second. Cold is influencing me. So CDF it's a cumulative distribution function, and what it does is the number you type in and everything below. So what I would do here is binomial CDF. So that's accumulating or a cumulative distribution function of 10, comma 0.3, comma 4, and what this will find is 4 or less. So like you can get away with PDF until it's like there's 25 trials, find the probability I get 10 or less successes. Then you gotta do PDF of 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. It works, it just takes you a while. It's still NPK. The only thing that changes is that C. So let's go back to this one here, and let's do the one we just did. So let's say n equals 10, p equals 0.3, and I want 4 or less successes. There's some people that are just like, I'm never going to deal with CDF. I'm just going to do PDF every single time. And when I get to that one on the test that's like 10 of them, I'm just going to take all that time and I'm going to go through it. Or I'm going to skip it and I'm just going to get a 95% of the time.
I would mess it up. I'd find a way to mess it up.
See, so some people are afraid they'll mess up the CDF and some people are afraid they'll mess up the PDF. So I'm just giving you both options. The CDF can be confusing at times, I will admit. But you're still going to do the same thing. N, P, K. You're going to label. And then that finds 4 or less. Because of the C, it's cumulative. So it finds that number and everything below it.
When you write it out, you actually have to label which one.
Yes. Yes. So the CDF is right below the PDF in the menu. So I get 0.8497, and if you really want to convince yourself it works, you could do PDF of 4, 3, 2, 1, 0, and add them up. I think you might just want to take my word for it, but you're welcome to check it out. Questions on the CD? Alright. I want you to try number 1 and 2. And those are both PDF, I'll just tell you. So I'm just kind of getting used to the calculator. But do number 1 and 2, write them out, label, get the answer, and let's just make sure we're getting them right.
Are they used
So
interchangeably?
they're not interchangeable, but you could find a way to use either one in every problem. But like in number 1, it says exactly 3 out of the 5. Is there any reason to use the function that does like this and lower? Or should I just use the particular? That's just the particular. That's exactly 3, like that particular answer. Does that make sense? when we get into some other ones, there is kind of like options. Like you could do this one with CDF, it would just be really. So like this first one, you should be typing in, it's PDF, because you're looking for a particular 3, specifically 3. That's the number of trials, NPK, always in that order. So there were 5 trials, that's your head. Probability is 0.7. You want exactly 3 successes, so NPK. Nevada Pizza Kitchen. 3087. Did you figure out why you have the 0 there?
Yeah.
She's just like right there for no reason.
No. I did the same. I did 0.65 because I didn't realize it was a new probability. I did it.
Oh, from the previous problem. Yeah. And it just, but they came out like
They
just
came
with
out
a 0,
like
right?
this.
Yeah.
Maybe it's only one number on.
How many got 0.3087? We got the PDF? Okay. Now your second one. Binomial PDF, your N is 6, your probability, it's a fair coin, so your probability is 0.5. And I want exactly 3 heads. So 0.3125. And this would be the same as if I did 6, choose 3. 0.5 to the third, 0.5 to the third. Like, this is what we're doing. This is what your calculator's doing. It's calculating this stuff. It's just giving you like a short. 0.3125, we good on number 2? Okay, so let's look at number 3. So this is where it gets a little more interesting. And you get kind of some choices, and you can decide for yourself like what you want. What's easier to you? What makes more sense to your brain? So 30% of the time, so B is going to be 0.3. 5 days, so N is 5. And then we need at least 4 of the next 5 days. We're looking for at least 4 successes. So K is actually 2 numbers. What are the 2 numbers that K is?
4 and 5.
K is 4 and 5. So there's 2 ways you can do the problem. I think for most people it's easier to do PDF of 4, PDF of 5, and just add it together. Like I'm going to particularly find 4, I'm going to particularly find 5, I'm going to add them up. So let's start with it. So I have a binomial PDF 5.35. And then 5.34. And add those 2 up. And I don't even care about typing it in, I just want you to write it. I mean, I guess we can. I'm going to type it, so let's roll with it. So I get 0.03078. You can save. Are we okay? The PDF one? The CDF one's more confusing, so I want to make sure you're all with me before I go through it. So for CDF, I'm going to start off with binomial CDF of 5. So 5.35, and that's my NPK. But what did that just find? Including, right? Yeah. And below. So this just found 5, 4, 3, 2, 1, 0. Well, which one don't I want?
3,
2, 1, and 0. So I could get rid of them by subtracting binomial CDF of what? of 3, because that would get rid of the 3, the 2, the 1, and the 0. And what are the only 2 numbers that are left then? Are the 4 and the 5s. So you can do whichever, and these get more, I mean, these get mixed up, and there's different types. Some are like more than this, between this and this, less than this, less than or equal to this, more than or equal to this. So there's all these different scenarios, and you just kind of got to play with it and see which way is working best for you. You'll get the exact same answer here. If you want to take a second and type it in and check it. It just might be more difficult in your brain to do it one way than the other. That's up to your brain. You know?
CDF is easier when you have one number.
If you only have one number, use PDF every time.
Like CDF if it's like less than 5 now.
If it's like less than 8, use CDF every time. But if it's like between, then you get kind of these like gray areas where they can both work. Try 4, and I want you to try it both ways. Like just write out both formulas. See if you can write out both formulas for 4. And get an answer too, but the formulas are more what I'm looking at to see if you understand it. I would always start off labeling NP and K. And K can be 2 numbers, K can be 3 numbers, K can be 4 numbers.
It wasn't that mean. It said never appeared.
That's not disrespectful.
I know, but still, you know. We should just bring one in.
Oh, I was thinking past away, like never died.
Well, perish, but you go
Yeah, that's.
I mean, it's kind of sensitive, so big.
Oh, but that's like RIP. Never pass away.
I thought it was going to be like no plane.
Okay, bye. Oh.
Dude, that's what I thought it was going to be. You were acting like it was so disrespectful.
Yeah, no, I was trying to think of something horrible. It wasn't that, yeah. I didn't want to say it was shit. I was asking like 14 times. So. It does. I got 0.563. Either way, right? Like, doesn't matter which way you're doing to get it. How many got 0.563? We got it? Wait a second. You still working on it? Just type it. What? Did you do PDF or CDF?
You said at least 3?
Yeah.
Oh, I could
most common kind that the AP asks. They like this at least once deal. So, I eat breakfast 80% of the time. What's the probability in the next 5 days I eat at least once? So n equals 5, p equals 0.8. And what is k?
1, 2, 3, 4, 5.
1, 2, 3, 4, and 5, right? So, I don't want to do the PDF way, although you could do the shortcut with this too. But one way to do this would be do PDF of 1, PDF of 2, PDF of 3, PDF of 4, PDF of 5. Add them all up. I don't want to do that. I don't think most of you want to do that. But is there a shorter way I can do it still using PDF? Think about a Venn diagram. If 1, 2, 3, 4, and 5 are over there, what's over there? 0. There's only 5 days. So the only other option is 0. So if I found the probability that I ate breakfast 0 days, what could I do with that?
1 minus 0.
1 minus, and that'll give me my answer. So that's an approach that you could use. So I could do 1 minus binomialpdf of 0. So if you think about that, at least 1 and never are opposites, right? If you've done something at least once, that's the opposite of never having done it. As soon as you do something at least once, you can't say I've never done it. Those are opposites. How many of you have jumped out of a plane?
Come on, too early.
I was thinking of like,
Jumped out of it.
I was thinking of parachuting. Yeah, it was a holiday. You know, if you raise your hand, you're in this group. If you don't, you're in this group. And they're completely opposite groups. So if you type that in, did you guys get 0.99968? Think through this spot right here. If I'm going to do 0, if I'm putting 0 in this slot, does it really matter if I use PDF or CDF? Isn't CDF this number and everything below it? Well, 0 and everything below it isn't that the exact same as 0? So, like, you really could use PDF or CDF if it's 0, because if you get down that low, there's nowhere lower to go, so it's the same idea. I'm going to show you one other way to do it. Just kind of think through a different thought process. So I could do CDF of 5. And just stop. Don't type this in. But just write this down. So what does this say? The probability I get 5 or less successes, right? Well, if I try something 5 times, what's the probability I succeed 5 times or less? 100%. I'm going to shoot 5 free throws. What's the probability I make 5 or less? 100%. There's no other options. So isn't this just 1? So isn't that the same? You know? So then, I mean, just a different way to think about it. Just trying to like wrap your brain around different processes. And then you can subtract the binomial. This gives you, 5, 4, 3, 2, 1, and 0. So what do you still have to get rid of? 0, and so get rid of that. And that's probably not the way I would think about it, but I think it's helpful to just see different ways and kind of get your brain practicing different approaches. So this is what I mean. You get choices and you get different scenarios, and you're like, okay, what about this? What can I use? Question on that? Try number 6. And then we'll probably stop after this and keep going tomorrow. You do have con due on Thursday. Same as always, not mandatory, but if you want to be eligible for any corrections or retakes that may occur, then you should do it. You don't have to take an SAT. You're all set with that, I think. What's crazy is this class would help you with that. There's like 3 or 4 questions that are stats based on every.
I do, but I'll sit down.
Yeah.
Usually,
Like people that are really like Maddie Armstrong, she said AP stats helped her on the SAT more than her. Like she's pretty good at math, you know. So.
what?
More. She was. I was like last semester, no, last year I was losing track. I think it's probably true. Yeah, she was trying to like exaggerate it a little bit.
Because AP stats, like,
But there was like,
it would be helpful.
it's helpful.
But innovative math, I thought, well, it's just like
It's just like
taking an actual.
Yeah, I think she underestimates how much that helps.
I got a question for.
I'm not trying to like trash talk Maddie Armstrong. Yeah. What's your question?
I got a question before I do anything. When it says at least 2, so
Yep.
you do 2, 3, 4,
Yep.
5, and 6.
Yep. But see, I wouldn't do 2, 3, 4, 5, and 6.
That's what I'm saying. That's a lot of work.
That's a lot of work.
Ew.
I mean, you could. So one way to approach this is to do PDF of 2, PDF of 3, PDF of 4, PDF of 5, PDF of 6. Add them all up. You guys all stopped listening before I even finished on that. So like, I don't have the attention span to do 2, 3, 4, 5, and 6 and add them all up. You get it, right? I know. So I would try to find a different approach, but if you can't, then just grind through it and do it that way. But we got n equals 6, we got p equals 0.4, and we got k equals what? 2, 3, 4, 5, and 6. So the PDF way, I'm just going to shortcut it and go like PDF 2 plus PDF 3 plus, because there's no way I'm writing all this out, and there's no way I'm typing all this in. You are welcome to. I'm telling you what to do, but that's just way too annoying. So I would go with the CDF route on this one. But that's up to you. Don't put yourself away, because this is an important one to go through. Just for getting used to how to think about these. So it should be 0.7667. How many got that? Right. So my thought process was, and I did this and then I realized it was a waste of my time. That happens sometimes. I did this because I was like, okay, this is going to find 6, 5, 4, 3, 2, 1, and 0. But what is this number really? It's 1, so I didn't even really need to do it. I wrote it and I was like, oh, yeah, that's just 1. And then this gets rid of, be careful you don't put a 2 here. I think that's a pretty common mistake. If you put a 2 here, you're getting rid of 2, 1, and 0. But you want that 2 in your answer, right? So you want to get rid of 1 and 0. And that's what this, what the 1 here does. So it should be 0.7667. Yeah.
So if you want to do PDF, would you do 1 minus binomial PDF
Of like parentheses, 1 and 0.
Yeah.
Yeah, or like minus minus. Yeah.
Teacher.
Yeah. Teacher.
It says binomial CDF. Or would you do binomial PDF? No. Next one. When you say minus.
No, I would do CDF because I want to subtract 1 and everything below it.
Oh my.
I want to subtract the 1 and the 0, so I'm left with the 2, 3, 4, 5, and 6.
I went in before school and it was
Yeah.
on Thursday. She was supposed to be Thursday. Didn't
That's 0.7667.
just answer email over the weekend, so I didn't even try to email her. So I go
Are we good?